All right, welcome back. Let's continue with setting up our characters. And another thing that we should declare early on here is going to be who the leader is, all right? And I mentioned before that it's always going to be that first person in that list. And even though we're not pulling anything in from the property list right now, we can go ahead and create a leader to use just for this video. So CS character, now check this out. This is going to be my character class right here. Now I'm getting that little error because yet again I forgot to import in something. So let's go and put in CS character, just import in the header file, and now I just put CS character, got my pointer after it, and I'm just going to write leader. That should turn green, and then any point after this I can now write leader, and it'll know what I'm referring to. So I'm going to write leader equals CS character node. I don't think I'm going to get an error from that, even though we haven't done a thing with this class yet, right? That's okay, so we can just write node in there. And now, oh shoot, let's put in here my world, add child, leader, and you know what, we can even leave out the position because by default that should end up being at 0, 0 anyway, but you know, if you wanted, you can put in here leader dot position equals CG point, but let's go ahead and skip it just because I definitely am later on putting that in with the property list anyway. So we're adding this child inside again to my world, so that node that's containing everything. We're not putting it in self, we're putting it in my world. And now we got a little bit of work to do in our character class to actually see what that character looks like. All right, so let's write our I need to be in the implementation file. Let's go ahead and write in our init statements, and I do that right here. So ID just means it's an anonymous object. Init if self equals super init return self. Pretty much all of your init statements look exactly like this. And oh, I hate explaining these things. Just note this part. Do initialization in here. All right. So anything we need to do inside of this, we're gonna, or anything we want to run immediately, we'll do inside of here. And here's a good one. Let's just see if the character actually ends up in the scene. So, all right, character is in the scene now. And from the code that we have, we should be seeing that. So I'm gonna go ahead and publish this. And there we go. So set up characters, and then character is in the scene now. There's really nothing to this character, obviously, but he does exist, or he or she. But don't want to, you know, be too gender specific here. I guess our knight's probably a he, but anyway, all right. So it's in there, and then let's go ahead and within our character class, let's kind of declare a few things early on. So, like we did with our level, I'm going to put at interface, and then I'm just going to put CS character, do these opening and closing brackets. Let's get rid of this and this and this. And I'm going to write SK sprite node character. All right. I'm going to put a little note here. This will be the actual sprite, or let's wait, actual image you see of the character. Okay. And that's what's going to end up having the textures of the character, our default image, anything that you know, the still images, the back images, they're all going to work off of this SK Sprite node here. So anytime there's a change to the appearance, we're just changing the texture of this particular sprite. And we will have other SK sprites inside of here. We're going to have a health meter inside of here and things like that. So again, our like our world, our CS character is a node that contains multiple other nodes. So one of them is going to be that particular sprite right there. And what we can do now is come in here to our init statement and write character equals SK sprite node with image named. And again, this will be something later on that we use with the property list, but for now, let's put in just character, and keep in mind that that is the name that we put inside of our image assets. So this guy right here, and we should just be able to add him. All right, hopefully that's it. Let's see what happens. Oh, thank God. He showed up. It doesn't seem like I have enough in here, but sure enough, that did actually put the character inside of there. So that is that's a really good sign. All right, so who wants to see some physics? This is stepping ahead of ourselves a little bit, but we can go ahead and do some of it now. Self.physicsBody. All right, now keep in mind that I'm doing this to self, all right, which is our entire CS character, our entire node, not just the sprite, or the, I should say, SK sprite node. So we're going to say self.physicsBody equals, and then we put in here SK physics body, and I'm going to put in body with a circle of radius, but notice there's some other options in here. The other one we're going to pick on later is going to be the body with rectangle of size, but for right now, let's go with body with circle of radius, and this is going to look for obviously half the diameter. How do we know what the diameter is? Well, let's just go ahead and grab that from character dot frame dot size dot width. That should do it, and then divide that by 2 because we're looking for the radius here, so half of that, and that's one line down. All right, so let's write in here as well, self.physicsBody dot dynamic, and you can see over here, well, let me just hit return. You can see over here it says a Boolean value that indicates whether the physics body is moved by the physics simulation. So by default it's yes, but let's go ahead and just make sure that's clear anyway. And then another fun one we can add in is a self.physicsbody.restitution, and that is best described as the bounciness of the physics body. Let's try something like 1.5 for right now. That should make it pretty bouncy. And self.physicsBody, here's another one, which we're actually going to disable later on. But for right now, let's go ahead and put it on. It allows rotation, so it'll allow rotating of the body. And then, let's see, there's a few other options we could throw in, but let's go and head back over here to the level. And if we were to put our gravity at anything other than 0, 0, let's try negative 0.9, or you can just do negative 1. Let's give this a quick run to see if it's working, and also to see if I've forgotten anything in the character. Boy, drum roll, huh? The anticipation is building. I hate it when it does this. No reason at all, really. Okay, there we go. And our little delay seems unnecessary now. Okay, so he's falling down, and he should hit the bottom, and there he goes. He's coming back up, and obviously he's coming back up higher than he started, and that has to do with the restitution being what it was. Looks like that'll go even higher up. So yeah, what we would eventually see here is he would probably get high enough to hit the top wall, and then he's going to bounce off that one, and then he'll just keep getting bouncier and bouncier until it's just some absurd, tennis match on a crack. So yeah, that's a good sign. Let's stop this. Okay, so let's switch back over here to our character class, and first thing we'll do is put in an import statement. So this will be import constants.h, and one of the reasons we're doing that is so that we can put in our category bit mask. And if you remember, we have over here a player category is equal to 1. So oh yeah, back over here. All right, so let's write self, and again this is referring to CS character as a whole, not just the image inside of it. Physics body that category bitmask is going to be our player category, and obviously the reason we're doing this is so that we can kind of check in on the collisions in our CS level and get some feedback about who is who is connecting with who. And to do this, we're going to need to put in here now self.physicsbody. Well, we're going to put in 2 lines of this. For right now, they're just basically going to be the same. Collision bitmask is going to equal wall category. All right, so we care about that one. And self.physicsbody.contact test bitmask is going to equal our wall category. And if I remember right, this is the important one in terms of getting our contact feedback. All right. If we set this one to 0, and we'll try this just as a test, I believe it's just going to fall through the wall itself. It's not even going to react to it. And when you're specifying these things, like the context that you care about, when you have more than one category, you put in this pipe here like that, and you can even put in player category as well. So if you want to test if the player has run into another player type, so let me put a little note here: separate other categories with pipe. Where's my pipe? There it is. All right. That does it for the character for right now. Let's go back over here to our level. And, we're going to need to actually put in here that that method to test whether the contact has begun. And again, we've already set in here our SK Physics contact delegate, so we are ready to go there. Where should we write this? I guess right here is fine. Did begin contact. That'll kind of fill itself in, and our contact inside of here, and I'm referring to this, our parameter has 2 properties to it. It's got body A and body B. Okay, so those are the 2 bodies that are contacting each other. And what we're going to do is create an SK physics body. And we can create both of them here on the same line. We just write first body and then second body, and we'll make the first body equal to contact A, the second body equal to contact B, and keep in mind that we have kind of a limited little universe right here in a sense, because we've only got one body that's moving, and we know that the wall is always going to be staying place. So at least for right now, it doesn't really matter too much who is body A and who is body B, and these themselves are pretty darn anonymous. We're just saying first body, second body. What we're not doing is saying player body, right? We don't want to make that assumption because we don't necessarily know that body A is the player. All right, these could contact each other in any order. All right, so just keep that in mind. And now what we could write though is if first body dot category bit mask, and the reason we had to cast these as an SK physics body is because first body or contact A and contact B don't necessarily have this category bit mask property, but our SK physics body does. So first body dot category bit mask is gonna if it equals our wall category, or put in the two pipes there, or if second body dot category bit mask equals wall category. Okay, now let's just put in here a log statement, ns log. Hey, someone hit the wall. All right, let's see. Sure enough, someone has hit the wall. Let's go ahead and add in a little bit of horizontal force to it, so we can see when they hit walls over here. And of course, we're not actually seeing all of the actual hit is occurring somewhere down here, because that's yeah, there it is. Hey, look, and he's actually rotating now. And of course, he's getting pulled back over there to that one side. Now, you know, if we did want to see everything, I suppose we could put in here. Well, we can nudge the scale down. That's one thing we could do. Yeah, we could do this, or you know what? We're getting close to the point. There, you can see the whole world. We're getting close to the point where I'm going to have the quote unquote camera start to follow this guy around, and yeah, for some reason that didn't move my boundary. Well, good reason not to go that route about it. Hey, yeah, like I said, in a little bit we'll move the camera around. Just note that there you go. That doesn't actually work. So let's go back over here to our character real fast, and let's set this to 0 and see what happens. He's not coming back. All right, so let's just assume he fell through the wall there. We could always go and test that again later. And then let's do this. Let's just comment out that line. And what that should do is it should leave out, the interactions should still occur, but it should leave it out of our output window here. So essentially now our method for testing contact, it doesn't care about this body in a wall category. Hopefully that makes sense. All right. Okay, so let's switch back over here to the level class, and I'm going to go ahead and paste in here these two methods. And one of the reasons I'm pasting them in, and I'm not going to do a straight teach, is it's because I stole these lines of code. They come straight from the Sprite Kit programming guide as put out by Apple. Actually, this line's a little bit different, but what's going on here is we are using these two methods to center our world around really the entire scene here around the our leader. And what we've got is this first method, which is we're overriding, and you can see over here in the quick help, it shows up as declaration, did simulate physics, performs any scene specific updates that need to occur after physics simulations are performed. Okay, so that is exactly what's going on. And then it says your scene subclass should override this method and perform any necessary updates to the scene. All right, so we're going to override it. We're going to put in our that method here, and we're just going to call this self center on node and leader. And if you remember, our leader is our main character. So if later on down the road another leader were to take over the leader position, or the character were to take that over, this is going to keep running just fine, and just basically use that new person to be the leader and center on them. All right, and so it calls this method down here, and it brings in this is our parameter, that particular node or our leader. And then the rest of this fancy math just takes care of, again, in quotes, figuring out where the camera should follow the, the camera should be centered around that particular character. And what I have not done is I've not sat down with a pencil and paper and figured out hypothetical positions for all these things. And doing the math on them, subtracting, stuff like that. I just said, hey, you know what, let's run this and see if it actually works. And that's exactly what we're going to do right here. We're just going to hit publish on this. And when our character shows up, all right, so he's going to descend. And look at that. Now our camera is actually following him around the screen. You'll notice that our collision circle, if you could see it, is actually probably a little bit too wide. What we could do is in our character class, we could shrink up the radius. Just over there it looks fine, but down here at the bottom it does at times seem like he doesn't perfectly hit that outer wall right there, and some of that could just be the simulator too, not running quick enough. But if you did want to adjust your radius, you can always go over here and you can make this, shrink it down some, whatever. And that's actually going to be something that we play around with in the property list anyway. So hopefully this is a good start for getting you guys involved in the physics simulations here with Sprite Kit. And of course there is a lot more to come, but for now we've got a kind of a bouncy knight inside of a, I don't know, caged world. All right, that's it for now.